did this one, client ID metadata, this one, and then first party app. Cool. Okay.
Good.
Awesome.
Okay.
Thanks a lot.
Mhm.
Okay. Good morning. So this is our second session, so you know all the procedure already. On the screen, you see the agenda for today's meeting, starting with Kelly, and then Aaron has a few presentations, or actually the rest of them. Thank you, Aaron. One-man show. And so let's get started. Let me throw up the slides.
Should Aaron just present identity training too?
Yeah, just to make it.
Make it easier.
Thank you. Let me pick the right slide deck. Is it this one? And confirm. Is that good?
Yes. I'll stand over here.
Slide control.
What can I forward here?
I have no idea. Okay, ask slides. Okay. How do I give you the slides?
Anyway, I can just let you know.
Or maybe I stop and then I give you. Haha.
Perfect.
Okay.
Okay. Hello, everyone. Kelly and I will present the ID training today. I think you took this picture yesterday, did you?
Right.
Yeah. We asked Brian for pictures, but he's never been to Dublin before.
Too busy.
So, yeah. Anyway, yeah, our agenda today is a quick refresher, and then we have a question to the working group about the.
Oh, we forgot minute taker. Oops. Can someone take meeting minutes? I need two persons actually. Thank you. Second person. Type in some notes. Don't do a transcript. Just the important decisions. Thank you, Peter.
Yeah. So a quick refresher, and then the problem we already kind of talked about last IETF, which is the confirmation key transfer. Yeah. What's in the draft? So like kind of as a refresher, we describe a mechanism to preserve identity information and federate authorization across trust domains. So you would have like two authorization servers. We refer them as domain A and domain B. And you kind of want to access a resource through domain A and then eventually in domain B. And our open issue from IETF 120 is how we enable sender constraint token on this. And this actually, as Kelly mentioned before, it's actually turned out pretty difficult, but we now have a solution. We believe it's going to work. Yeah. This is our general flow. You find here domain A on the left and then domain B on the right, and both of these authorization servers. And on the left, there is this client in domain B. And it's important to highlight here, we describe client as abstract. And there is two different deployments, how you can achieve it. I'll come to those, but it's important to note that the client is kind of abstract. And in the first step, the client in domain A will kind of try to discover which authorization server in domain B it's going to need. It's like kind of an optional step. You may know that already. And then the flow is basically two existing flows. The first one is a token exchange, where you kind of use whatever you have, client authentication, an existing access token, and so on, to exchange the token, whatever you have, to an authorization grant with your own authorization server. And then the next step, we use the assertion flow to actually present that authorization grant to the external authorization server in domain B. You get back an access token. With that, you eventually are able to access a protected resource. The first flow, or like the first deployment, is when the resource server is acting as the client. So you would have an inbound token coming to the resource server in domain A. The resource server uses that token to perform a token exchange, gets back an authorization grant. With that authorization grant, it's going to present it to the external authorization server, be like, hey, I have an existing assertion, gets back an access token, and eventually with that access token is able to access the resource. We refer to this as the resource server acting as the client. But in some cases, you may have a line of sight problem that the resource server is not able to communicate to the authorization server in domain B. And for this scenario, we also have the authorization server acting as the client. In this case, the authorization server in domain A kind of does an internal token exchange. So it kind of just generates its own assertion grant on behalf of the resource server and presents it to the other authorization server. And in this case, you just need line of sight between the two authorization servers and not between like sovereign outside resource server to inside authorization service, for example. So in this case, we kind of do a token exchange from resource server with its own authorization server. That's on the very left. Then the authorization server does like this internal token exchange, kind of mints an authorization grant, presents it to the other authorization server, gets back an access token, answers to the resource server with the actual access token for the other domain, and then that resource server is able to access resource server of the other domain. In both of these scenarios, it is different parties acting, and especially when we're now talking about sender constraint tokens, this is actually a bit difficult. And with that,
Yeah. All right. Yeah, that was very quick, Arndt. So, in addition to the processing rules which are in place for token exchange and authorization grant, we have a couple of additional processing rules in token exchange and the request. Um, uh, so the way that the resource server indicates that we want cross-domain solutions. In the token exchange request, the client includes in the subject token, the inbound token, and then in the requested item in return, it requests a JOT assertion, and requesting a JOT assertion, which it typically indicates it's intended for a cross-domain solution. That's when the authorization server in domain A knows to return a JOT assertion, and we've created a new claim. And I'll explain in the next couple of slides why we need this. But when the authorization in server domain A creates the assertion, it includes this new claim requested CNF, which all it does is it passes as a subclaim the CNF value that was received in the token, the inbound token.
Kelly,
Yes.
there's someone in queue. Do you accept questions?
Oh yeah, go ahead. Okay. Yeah, because we're going to finish quickly if we don't have questions.
Rahel, you want to come to the microphone? Okay. But I guess in that case, maybe continue.
Yeah. Questions at any time are fine. In the assertion generated by domain A, there's this new claim requested CNF that contains the CNF value that it received in the token. So that's what's the additional processing rules for token exchange. And then in the authorization grant, if the assertion contains this new claim requested CNF, then the authorization server in domain B takes the CNF claim that's contained in the requested CNF and uses that to fill the CNF token, CNF field in the return token. All right, so let's go to the next slide. Yeah, so this will hopefully clarify what I mean by those additional processing rules. So as Arndt mentioned, there's two deployment scenarios, one where the resource server is acting as the client, as the abstract client. We need some clarification in the document itself because there are in some sense two clients. There's the sender who initiates the original token that's inbound to the resource server, and it may not have a proof of possession on it. And so let's suppose it does, and domain A is configured to process, to initiate the sender constrained tokens. So when the resource server receives the inbound token, it packages that up as the subject token field in the authorization in the token exchange request, and additionally provides its own proof of possession, the CNF field, which contains the proof of possession for the resource server. All right, so once the authorization server in domain A receives that token exchange request, so here's where the new claim, the requested CNF, comes into play. In the authorization grant, in the assertion that authorization server in domain A generates, it includes in the requested CNF field the CNF claim for the resource server that was provided in the token exchange request. Yeah. Go ahead, Brian.
I know I've been following these discussions outside of this, but I'm a little thrown off by this one. I wasn't thinking that the requested CNF claim was applicable in this particular variant of the flow because the resource server is in a position to do its own proof of possession with authorization server B, and so could just.
Oh, I apologize. Yeah, I was talking about the wrong use case. You're correct.
Okay.
Yes.
So
yeah, go ahead. Yeah.
Yeah,
so explain.
It wouldn't apply here at all, I don't think.
Explain further. Yeah, so I apologize for the last minute addition of these slides. The authors just met over lunch yesterday to knock out the details, and so there may still be some hashing out even among the authors as to how this flows.
It's fun to see how the sausage is made here in front of us. In the context, the idea of the requested CNF claim is like a way to basically proxy a key confirmation element from an entity whom does not possess the private key.
Right, but this one does, right?
Right.
So you don't need the requested CNF.
Yeah, in this case.
Yeah,
so the resource server on that step, some of the arrows are there's the step between the resource server and authorization server B. If in fact you want to have sender constrained access tokens in the final flow, the resource server there acting as the client can just provide its own proof of possession to domain B authorization server, and authorization server B can just bind the token as per usual in the return there, and everything kind of works. So that it's just not necessary or applicable in this.
You're correct. I apologize.
Okay.
Yeah. So the requested CNF field is really when the authorization server is acting as the client. So yeah, I apologize. There's no need for it here that the resource server is providing its own proof of possession which then gets sent over to the authorization server of domain B in the authorization grant. And then once the authorization server in domain B has the proof of possession for the resource server, it includes that in the CNF field in the returned access token. And that's what we really want is, so working backwards at the bottom middle yellow and blue box, what we really want is that access token bound to the resource server in domain A. And so even without the requested CNF field, the authorization server in domain B is able to still populate the CNF field in the returned access token with the CNF, the proof of possession for the resource server. And that's ultimately what we want, like I said. So yeah, we got some people in the queue. Go ahead.
George.
Hey, Kelly.
Hey, George.
Good morning. So I guess that all makes total sense. But in the context between the resource server and the authorization server, then we're just treating that as the resource server validates the proof of possession on the inbound from the original sender, and then just basically passes it along, right? And the authorizations, there's no sort of like additional, right? There isn't any way to do additional proof between the resource server and the authorization server of that thing, right? So there wouldn't be any real buckets, any real sort of additional logic between the resource server and the authorization server. It's just the standard token exchange for an assertion grant, effectively treating the access token as a bearer token, because there's some level of trust between the resource server and the authorization server, right? You could do mutual TLS or some other client authentication mechanism between the resource server and the authorization server to sort of cover that trust piece, right? And then you get the proof of possession, as Brian and you were describing, between the resource server and the authorization server.
Correct. And one thing you pointed out is that the inbound token from the sender could be sender constrained to have a proof of possession for the sender in it. However, the resource server may not be able to validate that proof of possession. And so that's one of the fixes, one of the requirements. I'm going to let Arndt talk to that because he initiated that.
All right, so that's like a variant of this resource server acting as client, right? I need to be able to accept both inbound sender constrained. Do we not have? I mean, so I've done this before, right? Leveraging, the resource server doesn't know how to process proof of possession, and you can sort of, proxy it into the token introspection endpoint or something of that nature as a way to do this. But that's the use case you're trying to handle, right? Where the resource server doesn't know about proof of possession and is going to use some other server as a way to validate the proof of possession. Because my guess here, right, is the resource server is going to perform some action. It first needs to know whether the inbound access token is valid for whatever the resource server is going to do. Then it's going to contact the authorization server to get to the resource server in domain B. And so that seems like two distinct steps, one of which can be out of scope for this particular spec. Anyway, go ahead, Arndt.
Is that actually a sort of like a hard assumption that you want to design a solution where the resource server in A doesn't understand the sender constraints access token?
I think no, like between sender and resource server, it's like as before, as you would do proof of possession, right? Resource server validates proof of possession of the sender, and you can see it here that proof of possession is within the access token, so that matches, right? The problem is the key is with the sender. So the resource server doesn't have access to the key, and then it's basically forwarding a bound token to the authorization server, but it's not able to provide a proof of possession with it because it doesn't have access to the key in the first place. And that's why the access token and the CNF are separate in this token exchange request. And that is one of the big struggles we had since like basically half a year ago. How are we going to do this? Because the resource server may not have access to the key and cannot then build this proof of possession MTLS or depop. And what we now do in the spec, we kind of say, okay, if the entity that initiates this token exchange request is not able to provide proof of possession based on that access token, the client authentication must be used. And there needs to be some sort of trust, as you mentioned, George, that the authorization server basically trusts the resource server that it has performed proof of possession and made sure that the sender is actually the correct holder, if I'm making sense.
No, you're making sense. Great. So effectively, the boxes for this particular resource server acting as a client, there wouldn't be any. The boxes between the resource server and the authorization server wouldn't effectively contain. So when you talk about this CNF resource server proof of possession, is that intended to mean to represent effectively client authentication between the resource server and the authorization server, or should those boxes not be there in this particular flow?
I think the authorization server in domain A still needs to know what key it needs to bind the authorization grant to. So it needs some way to indicate, hey,
gotcha. Okay.
Server, right? Otherwise, if it's just client authentication, we may not have data for that confirmation claim.
Fair enough, because we're trying to proof of possession bind the authorization grant. Thank you.
All right, so no requested CNF is just a straight up token exchange in return for an authorization grant that now is bound to the resource server. And so the authorization grant, sort of the top middle, contains the information needed for the authorization server in domain B to include the CNF for the resource server in the access token, which is what we wanted ultimately, because when the resource server in domain A sends the access token to the resource server in domain B, we would like the resource server in domain B to be able to verify the proof of possession in the access token. So I think Brian has a comment and adjustment.
Yep.
So
about 8 more minutes.
George said we wanted the authorization server in domain A to bind the authorization grant to a key in possession of the resource server there. And Arndt, you said, yes, that's what we're trying to do, which is fine, but that feels like it's completely broader than the scope that we had previously discussed. Going back to the last IETF meeting, you may recall my ranting about each of the different stages in this and sort of how difficult it is both to talk about binding tokens and sender constraining each token in each step. And following from that, we sort of talked as authors, and my understanding, Kelly, was that you wanted to kind of take out a lot of that complexity because it just was beyond the scope of what you were trying to accomplish, and only focus on facilitating the binding of the final access token, which is not what, like, binding the authorization grant is a different thing. And
yeah, you're correct.
And it's fine if we want to do that, but there's different facilities involved in that. That would involve putting a CNF claim in the grant itself, probably defining a new grant type to make that explicit and so forth. So just, I don't know, trying to.
No, you're right. Yeah. So yeah, I apologize. Yeah. So in this case, the assertion is the assertion, the authorization grant is the one place where nothing's bound, right? But it has the information it needed to return the access token with the correct CNF field in it. I apologize for the confusion, and I appreciate Brian's addition and George's question. Um, as I mentioned, these are very fresh slides and do contain some inaccuracies, but we do have a PR that aren't created that has has all this information spelled out. The additions to the previous version of the draft haven't been published as a new draft, but are in GitHub as a pull request from Arndt.
Hey, Kelly. Excuse me, Dean Sachs. Uh, As you're presenting this, I'm finding it very difficult to follow just because there's a lot of resource servers and access tokens and stuff lying around. Next time, can we name or number these in some way so that we can identify them explicitly against the slides? Because I'm just having a hard time following it. I'll go back and read the draft and hopefully catch up from there. But from a presentation perspective, there's just so much flying around. It's really hard to follow. So just some advice for next time, perhaps.
No, I appreciate it. And so what would, just to clarify, what would we, so
For example, the resource server and the authorization server, just call them resource server A and B and so on. So,
Yeah,
and
right, that's,
also
that's,
the errors,
that's the way it is in the,
Yeah.
in the document.
and also the errors are like the different authorization grant access token, like give them a number so
Yeah.
we know which message we are currently looking at.
Exactly.
Right, yeah, that was in the slides
Because
that
you are
aren't
deep
presented.
into that with tons of meetings, but
Right, yeah. So in the slides that aren't talked to, each of the steps are labeled A through G, but I left them out here.
Okay.
But yeah, and yeah, that would be very good.
All right.
I
Thanks, Kelly.
appreciate that.
Appreciate it.
Yeah, thanks. All right, so I guess we're running shorter on time than I anticipated. So this is when the authorization server is acting as the client. So in this case, the resource server sends the authorization server the access token with its proof of possession. The authorization server then does its internal token exchange where it takes the inbound token, and this is where we need the requested CNF because we again ultimately want the last step where the resource server A sends the access token to resource server B to be bound to the resource server A. And so in order to carry that CNF claim throughout the process, in the top middle, the authorization grant that is generated by the authorization server A contains this requested CNF field, which contains the CNF claim from the resource server A. And when authorization server B receives this authorization grant, it returns an access token by taking the CNF field inside the requested CNF claim and uses that to populate the CNF claim in the returned access token, which gets returned back to the resource server. And then we have what we want, an access token bound to resource server A that resource server B can then validate. And I think, we have a couple more slides, but we may pass through them. So yeah, let's go to the next slide. All right, so these are the open issues. I'll let Arndt talk to these.
Yeah, like the whole way this works is kind of described in the draft, and it's very difficult to make slides. We struggled a lot because there's all sorts of different keys in place and resource servers and authorization servers. Yeah, it's not it wasn't an easy problem to solve, and we hope we've solved it now. These are the remaining 4 issues on this. One of them is also to clarify this client terminology, because we are like kind of talking about 2 different clients. There's maybe like an OAuth client, and then we have this abstract client, so we need some sort of different name for it. That's issue number 100. The other ones, they are basically about this proposal, how we want to, like the open issues for this proposal. Yeah, we already had discussion on it, but yeah, generally, like we were hoping to kind of get some feedback from the working group on this requested CNF, or if there's alternative ideas, we're very open. So yeah, please read the draft or raise your hand if you have alternative ideas.
Yeah, I think it would be, for me, it would be good to know on who has read the current version of the document, which contains some of that material. Like in the room, raise your hand to give me a sort of a quick impression. Oops. So that's not great. I think, like, obviously there's a little, at least I would call it, there's a little bit of complexity. And maybe I could have a few people to take a look at it, provide some feedback, because I think just looking at the slides are probably not going to do it. I think that there's a little bit more homework that needs to be done. This complicated things, like we knew it when we started, right?
Yep.
So
Just to clarify, this stuff isn't actually in the draft yet. It's in a PR.
in a PR. Even-
Further,
So
yeah.
maybe then
We're gonna merge the PR, then publish it to Data Tracker, and then maybe send out an email to the
okay.
working group. Like Aaron, because you profile this, your feedback is going to be very important, and others just like have a look. And even if it's too complex to understand, we need to change the wording and maybe add more stuff and so on. Yeah, so even that feedback will be very important.
Could I have a few volunteers to then look at the published document? Like I see Tony being super excited. Tony, are you? Yeah. I mean, would you volunteer to have a look at it? Could. Aaron, obviously you have to, because otherwise you are not going to profile it. Aaron, someone else, at least like one more person. Don't be shy. That's a. Oh, Dick volunteers. Oh, no, he doesn't. Okay. One more person, like. George says, okay, excellent. Thank you, George. Or did you volunteer him? Oh, okay, good, okay.
Yeah, so this is like this token binding is the last big thing we have in this draft. So once we've kind of have it and we got the feedback and we kind of solved the feedback, we are probably ready for a working group last call. Yeah, but this is like now like the feedback we got, and generally the feedback we hope we will get. It's going to be like one of the last open topics on this one. Yep. Perfect. Thank you.
Cool, thank you, guys.
Okay. Thank you.
Which one do you want to start with?
We'll do
The identity assertion.
I'm so short. There we go. Can you give me?
You can. I think you can just request. Did you request?
I did.
Okay, then. Should work. I did.
There we go. I had to choose the slides from the list even. I got full control. All right. Hi, I'm Aaron Praki. This draft is a profile of the other draft. So I looked at that draft a while ago and believe it or not, said, that looks like it'll solve my problem. So I want to give a more concrete version of actually applying that draft to a very particular use and talk about how what we were doing with it. So this is at that link right now. You can go find the draft. The premise of this and the use of this is in the enterprise context, where there is an enterprise IDP and a lot of different applications go and do single sign-on to that IDP. So that's just for the context. And there are going to be many different applications within the enterprise that are used throughout someone's day. Those applications sometimes need to actually talk to each other. For example, if you are in a wiki and you drop a link to a resource in some other application that also does single sign-on, that wiki would like to unfurl the link and show a little preview of the text. That means that app needs access to data in another app, both of which share the same enterprise IDP. That's the trust domain A. This is currently what is required to make this work is the end user has to actually go through a traditional OAuth flow between the two applications, essentially completely outside of the context of the enterprise IDP, talking directly. So application A does an OAuth flow to application B. That's crossing the trust domain. The user sees a consent screen, grants access. Those two applications can talk to each other. So essentially, what ends up happening is this, where the applications do OAuth directly to each other, n times m, lots of different combinations, lots of user consents. Meanwhile, the IDP that actually the users have used to log in doesn't know anything about what's going on in any of those grants. So the idea is to take the single sign-on relationship that is currently used to get into the app and extend that to also authorize API access between the applications, essentially letting those applications share data across each other, all under the control of the enterprise IDP, which is in the other draft, trust domain A. So this is essentially the summary of the identity chaining draft. There is some sort of token input used in a token exchange that results in an authorization grant. So that's the token exchange step. Second step is that authorization grant is used to request an access token from the trust domain B. And then they can go and do the resource access. I think George in the chat just at the end of the last presentation said, wouldn't it be a lot easier to talk about this in the 3 separate stages? These are the first 2 steps. I didn't put the arrow in for the resource access. But generally, yes, I agree. It's easier to talk about that way. Here's the other way to look at it. So the client, in this example, it would be one of the applications like the Wiki app it needs to go access data from, for example, the chat app, which is in a different trust domain because it's a different application. So it's going to actually go and do a token exchange with whatever it has. In this case, it would be an OpenID Connect ID token, or it could be a SAML assertion. Do a token exchange to get this authorization grant, take the authorization grant to request an access token for the authorization server of the chat app, and then it can go and use the access token to request data. The reason that this works is because both of the applications do share this identity provider through their normal single sign-on, the OpenID Connect or SAML, so we can use that relationship to actually link the 2 applications. So I kind of wish I had a slide in here that like divided this up into the trust domain A and trust domain B in the last draft, but essentially, I'm kind of pulling apart trust domain A into 2 pieces because the client application here is trust domain A along with the IDP for that first step. Trust domain B is the resource application itself has its own authorization server because like this is a fully functional OAuth system also. So the trust domain B is basically just this resource application. George?
Yeah, I think in your particular case, the critical element is that all trust domains, B, C, D, E, whatever, use the same IDP. So they're trust domains from an authorization server perspective, but not from an IDP perspective. There's like one overarching super domain, which is managed by the IDP, and then these individual trust domains are are managed by their separate authorization servers, but they're sharing that global IDP, which allows for the trust as you put with the dotted line.
Mostly yes. The one thing I would add to that is that this relationship to this IDP, these applications might have the same relationships to other IDPs as well. So there's actually even more combinations of links between these that are possible. So it's not like this IDP like owns these applications. They just happen to be configured to those applications for single sign-on for this one company. But this chat app has other customers with other IDPs that are also used for single sign-on to their users. So
yeah, makes sense. It might be interesting to draw a trust domain kind of a picture.
Yes, it would. I agree. I don't think I have that. Okay. Why profile the identity chaining draft? If you look at the identity chaining draft, it's it's describing these building blocks, but it leaves a lot of the things, a lot of options open and a lot of flexibility for the inputs. So like, for example, the first token on the input to the first request is how it's obtained is actually out of scope. In my profile of it, that initial token is obtained through a single sign-on, so it could be either an ID token or it's a SAML assertion. Doesn't actually matter which one. So similarly, that input to the token exchange step is flexible in the identity chaining draft, just like it is in token exchange. I think it just doesn't mention anything else beyond what token exchange talks about, which means token exchange says any kind of token is fine as the input. In this profile, it is limited down to only ID tokens and SAML assertion as the input tokens for the token exchange step. Similarly, the cross-domain trust relationship is out of scope of the identity chaining draft. It's just because you can apply it in a bunch of different ways. And in this example, the cross-domain trust relationship is the SSO relationship from both domains. The other part here is because we actually need all the parties involved to interoperate in this use of this profile, we actually do go and define the claims that are in the JOT that is used to bridge the trust domain. So the identity assertion authorization grant, which is the name of the draft, that grant is the JSON web token that is used as the output of the token exchange and the input to the access token request. So that actually goes and defines the semantics of those claims because we need to know what they are so that all the parties can know how to validate them. So this is step one. This is the token exchange request using in this case, ID token as the input. So this is just a use of 8693, where the resource is going to be the authorization server of the cross-domain, domain B authorization resource that it's trying to access, or the token endpoint. The requested token type, that is defined in this spec because requested token type is a empty slot you can fill in token exchange. We're saying it's this kind of token, which means we're actually defining the claims in that token, which are this. This is a very nice use of the token type NA because it is in fact not an access token. It is a cross-domain authorization grant. So it is token type NA is the output of the token exchange step. This JOT then has the defined claims with semantics that are defined in this draft. I think I opened it up here. Yeah. So it's saying which is the authorization server that issued it, who's the audience. The client ID one is tricky because we have to be able to cross domains with the client ID. It may also include scopes that application is requesting at the other resource. So then the client will take that new assertion and take it to the resource server of the resource application. In the other draft, it would be trust domain B. Go post that over and say, I need an access token. Here's this IDP says it's okay for me to do it because here's this grant that proves it. And then it would get back an access token that it can use at the resource server. And this access token is not defined in the spec or anything. It's just whatever token type that resource server would have issued in its own OAuth flow. So it may or may not be a JOT. It could just be, it's a bearer token, whatever. No changes to the token response there. Yeah, sorry for the UTF-8. I heard you, Brian. I don't know how that happened. Yeah, I think it's from I think I copied it from OAuth 2. I think that's just the OAuth 2 example. Yeah. Okay, so this is in development now. We are like actually, we did a prototype a couple months ago. It is now in progress in real production in the Okta IDP. It is going to ship at some point. We are working on it. We also have been working with Atlassian as the wiki application to actually work on a prototype as well. And they are working on it along with us, trying to progress this in parallel. There are a handful of other companies we've been talking to who are interested in this because it does solve an interesting problem for them, mainly the problem of bothering users all the time in the enterprise context, because it's not a particularly nice experience when all the data is actually owned by the enterprise company anyway, and it's not even. So I mentioned in the chat about the consent being moved, and yes, like that's the entire point, is to move the consent management of cross-domain applications to the enterprise IDP, because it is the company's data resources, and it's not even really the user's choice to share it across apps or not. So that is, that's the status.
Dean.
Dean Sachs. Aaron, I like this. I like the idea. One of the things that comes to mind is a concern about, use the example of, Wiki and some other service that you want to be able to unfurl those URLs in the Wiki, right? How do we ensure that the Wiki isn't inadvertently sharing that access across different users now? So there's a trust issue here, a transitive trust issue that I don't know how we solve. I see it as important, but it's an implementation issue in the Wiki and every other downstream service. So you're essentially extending that trust across those services in a way that you may not be able to verify.
Well, okay, so the maybe it wasn't entirely obvious. I don't blame you for missing it, but the input token that's used is actually a user's SSO token. So that input is in the context of one particular user.
Okay.
So the access token that results from all of this is still in the context of that one particular user. So yes, when that access token is used to fetch data in this application does need to know which actual user it was issued to and do all the authorization processing properly. But that's no different than what it currently does with access tokens that it issues to these applications through OAuth.
But
through
would
app-to-app
that
OAuth.
the initial token, wasn't that the ID token, right?
Yes.
And
yeah.
so that would have to contain all the authorization decisions?
No, so all that it needs to do is identify the user, because the authorization is all handled in this resource application today.
But I think that's what it's like. One worry is that like obviously mixing users, you're saying that's not an issue because it's all in the context of that user, but then there's also the question of like the authorization decision is kind of like implicit because it's kind of decided by the IDP, not based on what's in the token.
So yeah, the sort of unspoken things in here are that the IDP has some way to know, for example, whether this application is allowed to talk to this application and whether this user has access to either or both applications. That's all stuff that is policy in the IDP and doesn't need to be expressed in the spec because it doesn't affect the
But it would be good
tokens.
to say that in a token that you're making this assumption. Maybe
I don't think so. I think firmly no, because so the IDP gets to decide whether or not to even issue this authorization grant in the first place. So it can just decide at that point, no, this user doesn't have access to that application, so no, you don't get the authorization grant. By the time that authorization grant is issued, it means that the IDP says this user is okay to access data in this application when this other application is requesting it. But ultimately, like this resource app, if you imagine it's a chat app, it needs to know what user is coming in to the API request, and it has its own policies anyway of which users can access which data in it, which may not even be managed in the IDP in the first place.
Yeah.
So
just
it's a very complicated authorization problem, but I'm trying to just sandbox everything into what each is already able to know about and process.
For me, the question was like, how much do you need to sort of write up a document in the document to inform the reader what is actually the unstated assumption here about how this works?
Yeah, I think the security considerations section in the doc probably needs to cover this fairly well. And I haven't read this recently, so I will go read again and make some comments. Thanks.
There's a handful of text in the security considerations. I can't remember exactly if it covers that exact point.
George is up.
So we're still relying on the client and the authorization server of the other app to have done all of their normal OAuth 2 establishments. Otherwise, when you send in the authorization grant, there's no way. I mean, like, because I saw in your authorization grant request, there was a, authorization header basic effectively doing client authentication. And the resource server right, would have no way to know unless that connection had been made out of band.
Yes.
Right. And to the earlier conversation, I do think it's important to sort of call out that the authorization server, I mean, the IDP has the ability to reset the scopes that get issued in the JWT authorization grant.
Exactly.
Right. That's the control element, that regardless of what the client asks for, the IDP is in control of what scope should be present in the authorization grant, identifying what capabilities the user has.
Yeah, exactly. One thing, so I didn't put this in the slides, but this is mentioned in the draft. Because we're trying to extend the existing ecosystem, these two applications currently do have a relationship. Like if you go and you look at any of your chat or wikis or whatever you're using, like they do OAuth to each other today, which means they are registered to each other already, and those relationships already exist. So, Slack has gone into the Google Developer Console and registered a Google application that represents Slack, and now Slack can do OAuth to Google, right? So we're trying to extend that relationship and manage it through the IDP.
Right, but it's a sort of a dependency for this to work, that relationship has been established. Without that relationship, this won't work.
Without the relationship, this as written won't work. I do think there's a way to make it work without that relationship. However, I don't think anybody would actually do that. So I didn't bother actually writing that down.
Well, no, that's totally fine, right? I just think calling out that it's a dependency.
Yeah,
and
it is mentioned in the draft as a prereq for it.
Awesome, thanks.
Hi, Justin Richer. So I haven't read the newest version of the draft yet, but I just wanted to add to sort of this the stream of conversation here that this is the kind of thing that is incredibly powerful in a very, very narrow, specific set of circumstances. And so when we have technology like this, we have to be very, very, very careful about how we actually position it within the greater space, because I can imagine lots of ways that somebody would see this machinery and immediately jump to abuse it. So like the cross-user, cross-domain case that Dean mentioned, like I don't see why somebody wouldn't just sit down and do that with this, even though this is absolutely not what this is meant to solve.
Well, that was actually my goal of trying to profile the identity chaining graph, because the identity chaining draft describes these building blocks.
Yes, no, I
in
understand.
an abstract way.
Yeah,
and I'm trying to put the rails on it and say, this is what this block is. This is what this block is.
And again, I haven't read the newest one, so this may have been expanded, but I would encourage you to be very, very prescriptive about what those rails are with this. Like, go as far as to say, this can only be used when the following set of criteria are met. And those can be like very, very specific. And if somebody goes and uses it off label and blows themselves up, they did that, right? But we should at least be really careful about how, sound guy realized how loud I was. We should be really careful about where this is positioned, because there's so much power in translating one assertion to another assertion to an access token here.
I totally agree, and that's why I've given very explicit names to these roles in this version, as opposed to generic authorization server, generic client,
and
these are very
really good.
Explicitly named.
That's really good to hear. I will read the updated version of the draft.
Thank you, Justin. We are running a little bit over time.
Okay. Yeah, that's all I have for this one.
Could yeah, I think this will obviously build on top of the chaining draft, and so I think if as the chaining draft sort of advances, I think we can then have a look at doing a working group call for adoption to figure out what the sentiment of the group is.
Perfect. Yep. I have to ask for slides again to share the next one.
That's okay. Sure.
Which, yeah. All right, hi, me again. So want to talk about OAuth for first-party apps now. This is a draft that I've been working on with George and Peter, and I think I have some quick recap of the background for this. Talked about this many times. Hopefully, this is not too new for people. Essentially, the motivation for this draft is that for the first-party applications, in particular mobile applications, developers want a better user experience than what we currently have on mobile, which is seeing this pop-up prompt and then going through a web page to log into the mobile app. The reality of today is that people are finding workarounds for doing OAuth in native apps. For example, just doing custom DIY things, really messing up their authorization servers, scripting hidden web views. Like, I've seen everything. And it's bad, and people are basically trying to solve this problem and doing it in non-standard and sometimes very dangerous ways. So that was the motivation for this. The very, very high-level summary of the flow is basically mirroring the web authorization code flow, where the spec talks about how the client starts the flow, does not talk about how the client or how the user agent interacts with the authorization server in terms of the user actually authenticating, whether that's password auth, multi-factor auth, registration flows, whatever. But eventually, the authorization server issues an authorization code, and then that code can be used to exchange for the access token. So the first-party apps flow does the same thing in mobile, where it defines how to start the flow, leaves a gap in how the actual user authentication happens, but the output is an authorization code, which the app can then use at the regular token endpoint. So it's essentially adding a new endpoint to start the authorization flow and manage the authorization flow for the application, the output of that endpoint being an authorization code. So by doing it this way, we can actually leverage all the existing building blocks of the OAuth world, including extensions that you would use at the authorization endpoint. All of those get turned into post body parameters to start the flow, but you can do anything like resource indicators, jar if you want. You can do, you can build on the specs, because it's just it just slots in. The actual user authentication is left out of scope of this draft, and it's meant to be filled in either by an extension of the draft or a custom implementation. The one exception is there is an error defined, or I guess a command defined, which is if the authorization server wants the client to start a regular web-based flow, there's a thing mentioned in this draft to say to the client, you cannot complete this flow natively, you have to go out to the web. And that's for situations where there is unimplemented logic, or if the user needs to do an actual like federated login of some sort, social login or whatever. So that is that's the one sort of out this spec defines. What's new with this draft? It's been adopted in the OAuth working group. Yay, cheers. We didn't actually make any changes to the draft between the last draft and the adopted draft. Wanted to just kind of leave it there. So that is that's where we're at right now. Since the last time we met, there's been a couple of new implementations of this. One was presented last week at IIW from WSO2. I have a link to his slides. He gave a walkthrough of his implementation with screen recordings and everything in there. So take a look at that file if you're interested. Very cool implementation. It's also open source, so you can go look at the project right now on GitHub at that link. There's a handful of in-progress implementations as well. There is a Microsoft implementation. It's actually based on an earlier version of the draft, so it's not exactly up to date with this one, but there's a blog post you can read about it there. Yahoo has been working on this and did a presentation at Identiverse. Auth0 is also working on one. We don't have any docs on that at the moment. And then there's a Keycloak implementation now you can find at that link on GitHub there. So I think that's pretty exciting. Next steps for this, the big question right at this point is how we talk about passkeys in relation to this. So Tim has been working on there's a pull request right now on the repo, and if you go to that link, you'll find a preview link to a built version of the pull request. Essentially, the question is, do we incorporate passkeys into this as one option, one of the actual options of how to move this data back and forth, or keep that as an extension of this draft and kind of keep that work by itself? But that's the main question for how we progress with this.
Any views on this topic? We talked about it last time already. Obviously, back then we didn't have text yet, so now we have. Has anyone had a chance to look at this? Yeah. Yeah.
Sure.
Go
Yeah.
for it.
I hope that Tim Capelli, I hope that text is non-controversial, right? It's essentially taking WebAuthn level 3 has 2 JSON methods and it essentially pumps those into a set of valid request and response from this. So shouldn't be anything that looks new in there. It's just the way it's being passed back and forth. Yeah, and just like it's very generic to WebAuthn, but the use case is passkeys. Yeah.
Sounds exciting. So it looks a little bit to me like we need a few reviewers on this one. It's obviously brand new. We just adopted it. You had presentations earlier, but still. So to have a few reviewers here, I think the document would benefit from. Dean, I see Dean. Dean, I see Andy. And Kelly.
I guess one consideration is is Daniel? Daniel's not here. The OpenID for VCI folks are interested in using this. There was a conversation last week. I personally think it might be a stretch because it's not first party. A wallet is not first party to the issuer in most cases. But I think it would be heavily influenced by this. But that leaves the question, if we already know there's going to be another use case, does that answer the question of whether these should be separate documents or part of the spec? Okay. I have no preference.
A question for you, Tim. So, like, I haven't looked at that PR. Is the approach you took is basically shuffling JSON payloads around, or is the solution to shuffle JavaScript around?
It's JSON payload too.
Okay.
Request response too.
Cool.
No, just a clarification question. Hannes, is the question to review the PR or to review the draft?
The draft. The draft is like brand new as a working group item. I think we should review it. It should get more people looking at it.
Okay. Is there also a request to review the PR?
Well, of course, I would encourage that to answer that question. Like, I got no feedback on that. That would be good as well. But I'm happy if you guys look at the document first, and then look at the implementation. Like there's a lot of good material in there in your slide deck. So if someone wants to dig deeper. Yeah. But it looks in like a good shape.
Dean Sachs again. One quick question. Just skimming the draft doc real quick. I don't see anything in there about the authentication that looks like it's out of scope. Either I'm missing it in my initial just very quick skim of it, or not. If it's not included in there, I would suggest the WebAuthn pieces be left separate. Not that I don't want them to occur. I just think they maybe need to be separate from the draft. But is the authentication included in this?
No, so the way it's written, there's
Show the diagram again.
yeah, so
Yeah, I thought in that diagram it was part of the already exists somewhere else, and we're not gonna.
so the gray arrows here are the out of scope parts of this spec and also the authorization code flow on the web.
Okay.
So the spec defines the blue arrows. So it says, here's the input to the authorization request. Stuff happens out of scope.
Okay.
And then eventually that endpoint returns, after the stuff has happened, the endpoint returns the authorization code.
Got it. So if authentication is out of scope, I would suggest keeping WebAuthn out of this, but I'll read the draft and read the PR with an open mind.
It certainly might, it might be cleaner to do it that way, especially because then we can also define another form of authentication later with some other thing.
Yeah.
Without it like being weird.
Sounds good. Okay, thanks.
There are examples in the draft at the bottom. If you go down to the bottom, there's examples of different options of how authentication could happen. So they're meant to be examples of an implementation, and they talk about things like the user input their email first at the beginning of the flow, and then the authorization server sent a code to the email, and then the user enters that code in one of these gray arrows, and eventually an authorization code is returned. Right. So there's examples like that. So there's just an infinite number of possibilities of ways you can do these flows. The WebAuthn being just one aspect of it.
Okay, thanks.
Yeah. I'll just second what Dean was saying. I dumped it in the chat. I think because there's some level of request response or this challenge response protocol that is also left out of scope, in the sense of how that works, that is part of the framework for the actual individual authentication methods, it would be useful to have, sort of an extension doc that basically puts the whole piece together, right? That sort of says, okay, this is how we use the OAuth for first-party apps with, one or more authentication methods. And because that way, then there's also that example of the challenge response mechanisms that are happening, but that are currently left out of scope. Yeah, and it could be in, what they did would be in another example of that. But given that Tim's done the work for WebAuthn, I think putting it in that context might be really helpful.
Yeah, I just wanted to mention this WSO2 implementation is a good example of coming up with an actual challenge response protocol and a framework for the authorization server driving the client. They've done the work to kind of describe this, to define this syntax in that middle chunk that says, like, here's how the authorization server asks for an OTP or an iOS native auth touch ID response or whatever. So they've done that work to do that kind of back and forth, and that's in their slides and in the client. And that could also make a good extension of this to standardize that kind of behavior when you do want that authorization server driven flow.
Can you go back to the diagram? Yeah, so Tim Capelli, again, I don't care if this is a separate doc or not. I'm just giving context. Yeah, the thought was you need the context, then calling WebAuthn happens in the gray box, and then sending the response happens outside the gray box. So again, it can be in there, it can be not. The one other consideration I think we have to have with the redirect to web is or not redirect to web, depending. The authorization server may need to tell the client somehow that this is not only a web flow, but it's the identity provider might also be doing WebAuthn. And that's something that's not always very obvious. Because, for example, if you use a system, embedded web view, you can't. Right. So we should also figure out how we can communicate that, because that's how developers shoot themselves in the foot. So for example, like sign in, if you sign in with Google in a web context, it will not run. You won't be able to use a passkey if it's running in the context of your app by design from security reasons.
Yeah, and just to be clear, the redirect to web option here is meant to be like, go do traditional OAuth according to the native apps BCP, where you open the whatever AS web authentication session custom tabs thing that where passkeys and all that stuff works. Yeah.
Yeah.
Right. Right. Don't actually do the embedded web view for anything. Yeah.
Hi, Justin Richer. I've said this every time that Aaron has presented this. That first blue arrow is par.
Yes.
There's
kind of.
No, it is. It's the second blue arrow that's not par.
So
and the thing is, redirect to web is indistinguishable from getting back a par response.
Yeah, and I believe what we've now done in this version, since you last mentioned that, is made it actually that. So
okay,
there's
so this is the par endpoint. We're not making up a new endpoint.
There is a reason why it can't be the par endpoint. And I think we mentioned it in the draft, and I don't remember off the top of my head.
Okay, I'll have to look that up
So-
because I was just reading the
But yeah,
working
it
group
is
version.
very,
It's so close.
very close.
Yeah.
It's very, very close. The part endpoint does not allow for anything other than the redirect URI to come back. And it's very explicit about that in the PAR, spec. So if, we can, see if there's a way to munge our way around that. There may be some other idiosyncrasies, but that's the biggest one, is that it's very clear that the only response is the redirect.
So we update that RFC with this RFC and say, well, actually, we meant for there to be flexibility. And in reality, it's JSON, which is schema by fiat. And it's either going to break someone's parser, in which case they don't support this anyway, or they're going to ignore it because they don't support this anyway, or it works.
I remember having this conversation now with
Right.
George and Peter, and that was, it was we felt like it would be more acceptable to not overload the PAR endpoint with this. But now that it's a working group draft, that's fair game to talk about as a working group.
I
That was the motivation for it.
I think it's something we should strongly consider as a working group, is updating 91 whatever it is for PAR, and updating the response to actually to handle this, right? Because if the fall through mode is just go to the authorization endpoint in the front channel, which it should be, then that is literally what PAR does out of the box. And so we should be reusing these components as much as it makes sense to reuse the components so that we have a consistent set of operations here. Additionally, and this is something that I've long felt has been missing in the OAuth ecosystem, if we figure out how to cram WebAuthn into this, then we've basically figured out how to cram WebAuthn into a bunch of other kinds of spaces, because we're now defining it in terms of here's how you sort of kick that off with an authorization request and the context around that actually makes sense. So that, I think, would pay additional dividends. Again, assuming that part works. I'm less clear as to what exactly that looks like. I'm looking at Tim here because I'm sure he'll figure it out. But to me, I think it would be dangerous of us to define something that is almost but not quite exactly like PAR.
I
We
saw a
should
lot of
definitely put that
Brian
on.
shaking his head.
Yeah, we should
Yeah,
definitely
no.
put that on the
Put it on the
sort of open issue list.
Yeah.
I think to keep track of this. So that would be good.
Brian disagrees, and I really
That's cool.
love to hear why.
Brian, jump over.
There are a lot of idiosyncrasies in PAR. Thanks, George. But they're there for a reason. It's very much a independent transport mechanism for a traditional authorization request. It looks a lot like this, only at that kind of flow level. It is not a lot like this in that the clients are not expecting or capable or even meant to be receiving a actual application request. It's like a dumb pipe for a back channel push of an authorization request, and it's intentionally meant to be that constrained. And I think overloading it would be more dangerous actually than not overloading, than trying to munge it together. I admit there are things that on the surface look very, very similar, but I'm show my age here. It's really much more akin to a SAML transport binding, just a binding at a transport layer, than it is to like an application flow, which is what this is kind of moving to. I am old.
I understand and recognize that was that is the design behind it, and that is very likely how PAR is implemented. I know that's how I have implemented PAR in a couple of different systems to date. But I think that I still feel that there's enough interconnection and overlap that we as a working group at least need to chase this down and decide definitively, is this really a new endpoint, or is this something that we can extend PAR to do, especially if to Brian's concern, especially if we can extend this in a way that existing PAR implementations can kind of like safely coexist alongside of this. If the failure cases of not supporting parts of this are fairly clear, then yeah, I think that we should be in pretty good shape.
I will track it as an issue, start a thread on it, and we can see what it looks like.
Maybe one quick follow-up thought on that. In sort of the default modes, the default mode for PAR, as you said, is redirect to web. The default mode for this is interact via API, and that redirect to web is a exception case that occurs not on that first, well, it could, but more likely occurs on somewhere in the middle period. So it is, even that similarity is a little less similar than it might at first appear.
Okay. That's a good good next thing to explore on this. So we will take a look.
Cool. I have a few reviews.
I did not expect all of my sessions to get put on the same day. I think there was a schedule change at some point.
There was.
Yes.
Yeah,
So
because of we had to reshuffle because of different reasons.
okay, great. So
Unknown reasons.
I've asked for the slides again.
Okay, sure. Yeah, I know.
Okay, now for something completely different. Client ID metadata document. Okay, this is something very new. We've been working on this with Amelia. This is a draft that describes how clients can provide their metadata through alternative methods to what we currently have today, which are out of band, not part of any spec registration at the OAuth server by the developer, or dynamic client registration. So client registration needs to happen for a number of reasons. The authorization server needs to know the redirect URI, importantly, the name of the app, the logo, what scopes the app may want to request, what kinds of client authentication it supports, a bunch of things like that. There's a handful of properties that are now actually in a registry, and dynamic client registration establishes that, like, here's client metadata that can get registered. There's currently two methods for registering this information at the authorization server. One is not part of a spec. It is the developer shows up at a website, registers as a developer, agrees to the terms of service, fills out a form, uploads a picture, blah, blah, blah. That's how I would say most of OAuth works today. The other one is dynamic client registration, where the client can provide all that information to the authorization server in a HTTP request, which may or may not require that client to authenticate that request. So that's great. However, there are cases where pre-registration of the client is not possible, in particular when that client developer does not have a relationship with the authorization server. For example, an open source chat application talking to a self-hosted chat server. Somebody has written the server code, someone else has decided to deploy it at a website, somebody else has made a mobile app, the user downloads it from the App Store. How does that app find the authorization server? Well, the user is going to enter it in some config setup screen somewhere. There is by definition no relationship of the app developer of that app and the person who installed the server on their own system. So there is no way for pre-registration to have happened. The only option is dynamic client registration at that point. So any apps that connect to self-hosted services, so that could be like a WordPress app talking to your own WordPress blog, a Mastodon app talking to your own Mastodon server. Essentially, whenever there is no actual central server where OAuth client registration is possible. And this is getting to be surprisingly more and more common. So dynamic client registration is basically the only standardized approach we have for this problem today, but there's a bunch of problems with actually using it in practice for this. So first of all, by definition, there is no prior relationship, which means there is no way to have authentication of the dynamic client registration request. So it's a public endpoint first. That endpoint has to accept post requests from any client that shows up with information and then store that information essentially indefinitely. Indefinitely because if a user logs in once now, they may at some point pick up their app again a month later and log in again, and the registration information is expected to be there because the app already got its client ID.
Sorry.
I think Brian's offended you didn't bring coffee back for all of us.
Oh, yeah, that would be.
So what ends up happening is authorization servers will end up building a sort of cleanup process to remove stale clients, but then the client doesn't know it's been removed. So the clients end up in an error condition of trying to start a flow with a client ID that no longer exists at the authorization server. So then they have to re-register, or the user sees an error, which is not good. So what ends up happening in practice is the clients end up doing dynamic client registration for every user login so that it always works, because that's the sort of lazy approach to fix the problem. And there's a real example of a Mastodon instance with 40,000 users with 400,000 client registrations in it, which is just not sustainable. And if you want even more examples of the chaos of this has caused, there's a link here to a thread on Mastodon.
There's
Neil, do you want to say something?
Hi, Neil Jenkins. Obviously, I've been looking at this because we're looking at doing this for email and stuff, and we have looked at what you're proposing here, but we actually think that the dynamic client registration is the better way of going. Like, I think this is an implementation problem, but no, most of the server authors we spoke to didn't think this was a big issue. Like, if you keep the registration around as long as there's an active session for that, and then you can delete it afterwards. If it registers every time it authorizes, so what? Mostly you'll give back an existing registration if all the details and it match all the details you have from an existing registration you have in your database. Like, I just don't think this is as big a problem as you think. Whereas the other way around, there's various problems with if the server has to fetch it, both from a security point of view of the XSSRF. I always get those things, but it's in your document, you know about that. But also just it's a failure point. Now, if I'm creating an app that wants to talk to the server, I have to also be able to run a website that has to be able to host this file. And if the server can't talk to my server for some reason, then my app won't be able to authenticate, even though that's kind of completely outside of this. Yeah, I'm not convinced this is a better solution. Maybe some people want it. I'm just saying that we looked at it and thought dynamic client registration is going to work better for us.
So there's two things I want to respond to there. So I agree that there is a way to do dynamic client registration for your use case in a way that makes sense, but it needs to be written down, because if you just look at the specs exist,
if people naively just
do
shit, then yeah.
But if you can write down the steps of well, one example is if you want to add client authentication to this, the client's going to need to establish its private key in the registration step. So that needs to get written down.
Thing that added, particularly here. Yep.
The sort of use an existing registration if it's already there. That's not obvious how to determine whether it's the same instance of the client or not. Do you want separate instances of clients, or do you want to share a client ID across multiple instances? Those are all questions that need to get answered in dynamic client registration, which are not answered. So that's all great. And like, I think that makes sense. And I do think that actually makes sense for desktop clients and native clients.
Yes.
And so your point about like there has to be a URL available. I agree that is a challenge for a native app. It's definitely possible, but yeah, then you end up with
we're focused purely on native apps. So if this is kind of purely focused on the web apps, I see there's the difference in.
So what I'm getting at is for apps that are on a web server where by definition there is a service.
Yep.
All the dynamic client registration problems are weird and out of place, but it's natural to sort of have this endpoint that describes the client.
Okay, I see that. Yeah.
So I think both are useful. Yeah.
Thank you.
Philip Skokan, hi. There is a little known RFC that follows 7591, 7592 that prescribes a means for clients to know that they have been actually cleaned up.
It's a management.
Yep. It's an experimental.
It's an experimental RFC.
Yep, but still.
No, Justin says
But
don't.
It is
Okay.
there. I'm just saying, if you're saying clients have no way to know, I'm saying there is a way to know. That's it.
Hi, Justin Richer. Ignore the fact that it's an experimental RFC. That was a political move to get it unstuck from the working group because some members of the working group didn't want to see it published because it contradicted with what their company was shipping. I'll tell you the whole story over a beer sometime. It's a mess. Regardless, yeah, 7592 does give a clients a way to find out. That is relatively clean, but requires more action on the part of the client, right? The client has to say, am I still registered? And if not, then I go register. And if I am, then I actually go do stuff. And in my experience, no client is going to be smart enough to actually do that. I had actually proposed at one point that we not actually have the read portion of the management spec, that it was really only kind of updating and deprovisioning type of actions, but it is in there. It is possible. I don't think it's realistic to rely on, just for the record.
And I think that's also to Neil's comments. I think there's a big difference in you have a small number of people implementing clients that are in a working group and talking to each other regularly versus you are in the public open web and everyone, it's a free for all and everyone's going to do whatever is the fastest thing they can get done and sort of what falls out from that.
Right, exactly. And I have another real world example similar to your Mastodon example with the Smart on Fire healthcare system. Uses dynamic client registration for many of the same reasons here. And those are also effectively ephemeral clients most of the time. So they have a relatively aggressive cleanup mechanism because their use case for clients that are tagged as, I forget if it's the grant type or something. I'd have to go check with Josh, but the last I saw that code, it had a fairly aggressive cleanup schedule, was my understanding of it, that said clients under a certain class, if we haven't seen a new access token for them in a while, then they're gone because we never expect to see them again. But that doesn't fit this pattern and use case that you're talking about. So
Justin,
I will let you actually.
Justin, I wasn't quite sure what you were saying about 7592. Are you saying don't use that?
Oh no, I'm saying use it. It works great. It's totally fine. It's called experimental because one rather large technology company didn't like it, and by calling it experimental, we could actually get it published by the working group.
Okay.
Forgot that history. Go to the microphone, Peter.
Peter's asking, I'll just repeat. Peter's asking, there's something that was not to be relied on? Oh, I'm saying don't put a lot of weight into it being an experimental RFC because that doesn't mean as much as some people are inclined to.
We can also like advance from documents and work on them again and get them to like regular standard struct documents.
Yeah,
because things change over the years. Right?
They do. But in all honesty, the management aspects of the protocol are far less used than the registration part of the protocol anyway. So there is a reality on the ground that it's not as well trod. And so I think we would have a hard argument to try and push that forward through the IETF process and IESG and all.
Okay, so let me give you an alternative.
Anyway, yes, go ahead.
Which
sorry.
So the alternative. I brief mention of one of Tobias's earlier drafts that does something similar, but uses the .well-known pattern, which has the well-known problem of multi-tenant systems and where that .well-known goes in paths. Which has just always been a mess. So I would ideally like to avoid all of that. So what this does is essentially it defines a URL that hosts the client metadata. So the URL is not required to match any pattern. It's just a URL. that URL is then used as the client ID in an OAuth flow. So the contents of that URL is everything that you would do in the dynamic client registration step. So it's that vocabulary, just reusing that vocabulary, reusing that registry. And then the authorization server can go and fetch that data. So one of the really cool things that it does is it essentially builds in the management of that data just by default, because the authorization server can always fetch the data new. It can cache it. You can use regular caching mechanisms. You can update the information if it changes, like the name or the logo. One of the other very cool things that it does is it actually makes it so that in web services that are using this, you can actually establish authentication, client authentication. So you can publish a public key in this metadata document, which is then used by that client. So there's absolutely, of course, no requirement that the authorization server do anything with this metadata other than use the string as a client ID. But the authorization server can fetch that data to display the name. If it has heuristics of whether it should trust that URL for some reason, whatever that reason is, it can use the heuristics to determine whether to actually show the name to the user or not. But one thing that is useful in that is that metadata contains the redirect URLs that are used for that client. So that acts as redirect URL registration. The metadata can include a public key. And it is required that those metadata documents are accessible so the authorization server can fetch them. So this is also really interesting overlap with how FedCM works, where FedCM expects you can again, assuming the preconditions of there is not a pre-existing relationship between the website you're logging into and the IDP, which is not every use of FedCM, but it's a couple of really interesting ones. You can use the client ID to bridge that gap. So I've done that here with this example of FedCM where I'm using my website as the IDP. I'm using this I'm trying to log into this website. There is no prior relationship. And essentially we can use this to get a much better experience than the user having to enter their email address or URL in a form, because FedCM can just make the pop-up appear, which is very, very cool. The other implementation now that we have is from Blue Sky. So they just launched an OAuth server in their product. It used to be just app passwords that were used for third-party applications. So now any app developer can go and create an application that talks to their Blue Sky account. And this is an example of the consent screen that shows up as an end user. I've entered my Blue Sky handle, aaronpk.com. I then see this screen, which I'm trying to log into this app called Front Page. They've decided to show the full URL of the client ID in this consent screen with bold on the host name. And I can choose as a user to accept or deny this. There's another one, it's called smokesignal.events. Those are the two that I found easily accessible that I could actually try and actually use. There's docs for their OAuth flow at that link. They've gone and defined essentially a profile of OAuth that includes a handful of RFCs, including Depop and PAR, I think, is in there. Yeah, this uses PAR to start the flow with the client ID of the client. There's Depop in there. There's I can't remember all of them, but anyway, they're at that page. Should we take questions from the queue? Who's in the queue?
Mike, where's Mike? Yeah.
This is a bigger discussion than I think we want to have at the mic, but the OpenID for verifiable presentations spec recently, and the DCP working group just spent months looking at how to distinguish different kinds of client IDs and landed on a solution that said, in almost all cases, you put a named prefix in front of it. And this usage would directly conflict with what's specified there using the raw URL as the client ID. Whereas if you prefix it, you could fit into that world. And again, this is a longer discussion. You can talk to Joseph or me or a lot
That-
of other people.
That doesn't seem like it matters for implementations like this, where they're only ever going to use this client ID type, right? So there's no reason to
It's
prefix
easy to
it.
think that at first.
Can't you
but-
use
but-
HTTPS as the prefix?
That's what Federation does, and that's what the DCP spec does, is said if it's HTTPS, it's OpenID Federation.
I mean,
And this could fit into Federation as well if you want. Again, this is a longer discussion, but there's, cross ecosystem considerations of using the URL as a client ID. We can talk later.
okay.
Hello, this is Matthew Siben from, I work at Blue Sky and I work on this implementation actually. And one of the main reasons we use this instead of dynamic client registration is we wanted to encourage client developers to build apps. And we figured that having to perform management was something that would make app development more difficult. Which is why and there is in particular another aspect to having to perform management is in the particular case of one client losing their credentials to access those management endpoints. Well, in a distributed system where there are over 500 more than 500 authorization server. One client losing their credentials to all those authorization server would require a lot of maintenance on all those authorization server to be allowed to answer those requests to, can you clear my credentials because I lost them. So yeah, and we also wanted to avoid those multiple registration and having to manage the client registration and clean them and so on. So yeah, this is why we came up with this solution for our implementation.
Thanks.
Joseph?
Okay, so yeah, just building on top of what Mike Jones said, there are I think at least 4 cases I know of where people want to use HTTPS URLs as client IDs. I think it's fundamentally a very bad idea to not be telling the authorization server how the client is actually expecting the authorization server to look up the data. As Mike mentioned, Federation is already using HTTPS, that's kind of deployed. So it then becomes very difficult for a server to use both this and Federation without having to go out and try both endpoints. And that just gets worse as you add more. And it also introduces a potential security issue that you could have a client authenticating with Federation and then authenticating with this. And the server might view them as the same thing when they've been authenticated with very different levels of security, essentially. The Federation one is quite well authenticated, but this is just a file that's been put on a web server. It's quite well authenticated as well, but it's very different. So yeah, I mean, arguably, we shouldn't have even had Federation using raw HTTPS URLs because it just encourages other people to do it. So I think we want to be very careful not to set a precedent here that it's okay because authorization servers that use this particular HTTPS URL case will only ever use it and won't ever use Federation. And as I say, there's 3 other cases I think that I'm aware of, some of which come from the VP spec, where you end up doing this. So I think, yeah, adding a prefix, I think, is very important to avoid digging ourselves a big hole.
This might show my ignorance towards the Federation spec. However, Aaron's proposal, the client ID is the full URL to the metadata document. Is that really the case in federations, or does the federation? No, it has an entity ID, which is sort of a URL without pointing to an actual document. And then I assume that there is a step in federations that resolves the URL, which is what Aaron was trying to avoid here.
You're correct that it's an entity ID, but it is syntactically indistinguishable from something using this method. The authorization server can't tell how to look it up, whether to just do a fetch or whether to append a well-known suffix.
Yeah, and I mean, I really don't think we want to dig ourselves into a situation where the authorization server is essentially trying to do regex matches on the client ID to try and guess how the client ID wants to authenticate. That feels like a route to madness.
This really only seems relevant if there's going to be a situation of an authorization server supporting federation and this, and those seem like completely at odds with each other. Like, I don't expect any situation where those are going to overlap.
Yeah, but there's other methods around. So there's somebody else that's the VP spec allows you to use X509 certificates with a sans URI to get a client ID that's HTTPS based. This is not going to be the only cases that people come up with.
And, federation is basically about trust establishment. I suspect there's going to be cases, if this succeeds, where you're going to want to do trust establishment with things that are not you. Just like federation can be used with OpenID Connect or not, and it can be used with OpenID for VC or not, et cetera, et cetera, et cetera. It's a mix-in. So it's actually, if you succeed, it's likely to get used with it.
Did someone check, some usability expert, on whether if you click on the page with the screenshot, whether users actually understand sort of who is actually asking? Because I could imagine, like in this case, it seems obviously because it's in bold, the domain name is the relevant part, but it may not always be true, right?
No, I think that's actually a really important part of this, which is again different from dynamic client registration, because with dynamic client registration, there's nothing to go on. There's zero information, zero context to go on if it was just a client showed up and said, here's my name and logo. With this, there's at least the domain name. And that's the one thing we have to go on as a user to know whether that's what I'm trying to do. So I think it's like...
But I'm saying, like, behind that domain name, there may be multiple different users. Like, think of many of the blogging websites, like it would create the impression to the user that they are actually authorizing some, like, let's say, some blogging website to give them access to, while in fact we are just giving it to user. Like, I'm not the user, but UI expert. So
this is saying that this website, so I was, in order to get to this screen, I was on frontpage.fyi. So as a user, I'm like on that page, I click login, and then it asks me to enter my Blue Sky handle, which is my account. And that's one user account. So I entered aaronpk.com. Then I saw this screen. And so now as a user, I've already seen front page FYI. I entered aaronpk.com. And now I see a screen that has both of those pieces of information. So I'm authorizing that one website to identify me on Blue Sky.
Yeah. Do we have some people who actually understand security and UI to also look at that?
I don't know what research has Blue Sky has done on that, but that's where I would expect some of that to happen. Yeah.
Okay. Do we have? David.
Oh, just adding to the client ID prefix scheme for resolution. The way that I looked at that is that you're similar to way back in the original OpenID 2 and OAuth 1. You're kind of claiming a URL. We used to use various things for that, like Yadas. But since we've had 11 years of evolution here, we have, I think with this would be 5 different ways that you could claim a particular URL. And so the scheme makes it so that you know which one they intended. So you don't want to have the same client ID mean that metadata could be resolved multiple ways, even if you only think one is going to be used by a particular site, because it is a potential security issue if an attacker has 4 other unsecured ways that they could upload metadata that AES might think is authoritative.
I'll be real quick. I think I know, Aaron, when you talk about DCR, you talk about it in the context of specifically only what is currently specified in the specs, as opposed to what people do when they implement it. Which is, I think, adding client authentication or adding some level of server, you could take client attestation that we heard about yesterday and combine it with DCR, right? And you would get this mechanism. So I don't think that that it's a to me, it's not a problem with the methodology of DCR, right? There may be some more things we need to write down.
Well,
That being said, I understood what the point you were making earlier was trying to do DCR from a web-based client adds some additional complexities that are not as relevant in the native apps. So are you trying to target this work at, basically web-based clients because, that's solving some additional problems that that aren't really as present in a native app scenario?
I think that this is going to be most useful in the web app scenario, but there's nothing that actually prevents this from being used in native apps also. So native apps would just have to host a URL at the website for the native app, which most apps have, with the metadata in it. And obviously then you don't get the per instance, private key,
Right.
but everything else works fine. So,
but you lose a lot of the value of what you're trying to get with DCR and mobile apps and mobile app impersonation and the rest of it. So I wouldn't want this recommended for native apps as a way to go. And the more ways we have to do effectively the same thing, the more confusion we're going to get in the marketplace. So anyway, those are just some of my concerns.
I get that, but again, like going back to the very beginning of this, there is a very explicit prerequisite for this, which is that there is no trust relationship or any pre-existing relationship between the application and the authorization server. So we can't rely on app attestation. We can't rely on registration as a developer or anything like that. And that's like going into it, that's the world we're in. So in that world, dynamic client registration doesn't add anything to, it doesn't help any, it doesn't add any value.
Yes, it does.
At least gives us a domain name. And I agree, it still has a bunch of problems, but we all, like, those problems just exist.
So anyway, I guess I feel like I could solve that with client attestation and DCR and get both what you're talking about and the value of DCR in that space. But we can have that conversation offline, right? Okay. I think we just need to be careful from a community perspective in having many ways to do the same thing without a clear understanding of what the differences are in the security properties that you're gaining or losing by choosing one path or the other.
Justin Richer. First, I agree with basically every concern that's been brought up so far. This is a space that is really, really, really difficult to sort out because you're not just talking about previously unknown connections being able to connect, like making a TLS or TCP connection and then data just flows. There's this whole separate application layer of trust that's implied by all of this going through that then has to be presented to the user in a reasonable way. So this is really, really hard to do. And we hammered a lot of this when we were working on dynamic client registration. And I know those same conversations have been refined as like OpenID Federation has been worked on that builds on top of it and stuff like that. And I wanted to bring up 2 key points here. First, dynamic client registration was always intended and built to be extensible with authentication type mechanisms. You mentioned that at the very beginning. I think that may have gotten lost in some of the conversation here. It has the weird like throw a token at it to start off thing to bootstrap it. I've seen people do other things with that, like do a client credentials and then register, and then there's all sorts of ways.
That's all great. We just can't do that here.
I understand. I am with George in that the client attestation gets you a very long way, as do captured URLs that you can attest ownership to and things like that. I think that there are some other techniques that are available today that weren't 10 years ago that we can probably work on doing that. The other thing is that every time I see a solution like this that is purely URL claiming, I flash back to the OpenID 2 days and the ESPN.com attack, which for those that don't recall it, ESPN.com had a star.espn.com type of registration where it looked like you were just logging in using ESPN.com, and then a different part of the organization allowed users to claim Aaron.espn.com as their personal sports page. And suddenly attackers had something in the namespace that was covered by the previously existing trust agreement with star.espn.com, because they didn't want to treat www.espn.com and whatever.espn.com as separate entities. And I'm not saying that is endemic to this, but that's what this immediately leads to, because that's how people will implement it.
I agree. There's a lot of interesting security considerations in this space, and a lot of that is also applies to just web hosting available on subdomains. Like GitHub went through this when they had to switch to GitHub.io for sites. It used to be subdomain.github.com, right? But I agree. There's lots of interesting stuff there. It's just that those are just problems of the space and have to get worked through. There isn't a way around it. We should list them all out.
Yes, I agree. Listing them is a good start. And considering the ramifications on the trust model, which you're arguing this is what this is bringing to the table, and this is what everything here is rooted in, is that trust model is going to be foundational to the value that this brings.
And again, just to reiterate, I'm not saying everybody needs to start using this. I'm saying that this has a use in a very particular situation, which cannot use existing methods like pre-registration, and app attestation barely makes any sense in those cases also. So this is just the space that exists. Yeah.
Okay.
So I only had a couple other slides. I'm gonna get through this because I want to talk briefly about the last topic too.
We have 8 minutes till the meeting ends.
Yeah. So I guess this is mostly just we already talked about it. I wanted to point out the implementations of this that exist or are planned. Blue Sky being the new one that's popped up. Mastodon is also now planning on doing this because they have this problem with dynamic client registration. There's an interesting discussion about how to handle local host and development clients for this. So that is something worth discussing. There's already a long thread on the repo for this talking about it, and some good. It's definitely some interesting concerns about how you handle that when the client metadata is not on the public internet because the authorization server is also not. Won't get into that because we don't have any time. Oh yeah, and here's some of the other topics that are interesting to discuss in this context, but there's already GitHub threads for this, so feel free to chime in. Cool. That's the end of that. Thank you for the discussion. Last thing on the agenda is OAuth 2.1 update. We only have 7 minutes, so this is going to be a short update, but that's fine. Main thing I wanted to get across here, I'm not going to do a full recap of OAuth 2.1, just that it's trying to solve this picture, which is the current state of OAuth 2. There's been a couple changes since the last draft, since we last met. My favorite one, I think, is this top one. I mentioned that the string bearer in the token type is in fact case sensitive, and it always has been. But insensitive. and it always has been insensitive. However, most people don't know that, and now there's an explicit mention in the spec with examples of different capitalization, and I almost added one with alternating upper and lowercase just to make the point. If somebody, okay, I guess I have to add it. I saw enough. Okay. Yes, exactly. The what? I didn't hear that. Extra credit for spelling something with the capitals. I like it. Okay. Okay, there's some fun things we can do there. Anyway, minor changes. There's still a handful of open issues. I think all of the big topics have now been discussed either in threads on the list or on GitHub or in past meetings. There's still a lot of open issues. They are all either relatively small things that I think we can just kind of work through as the editors. If you have any opinions about them, please chime in. But yeah, we're gonna do a push on this now to try to actually finish this, get over the finish line. The big things we were blocked on previously were the security BCP and the browser apps BCP, which are meant to be inputs to this document. So the security BCP is now, I believe it's in the editor's queue, right? So we can check that off as a blocker at this point. The browser apps BCP is waiting for the Shepard's write-up, so it's not quite done, but I think it's done enough to at least start pulling things from it into this, because it's not going to be a complete copy paste anyway. It's going to be kind of copying the main normative requirements into this. So that's all great. The goal here is to work through the rest of the issues, which are mostly minor things. I hope if anybody has strong opinions about them, this is the time to go and look at them. I'm going to try really hard to get this so that we can ask for working group last call in the beginning of next year, ideally before the next meeting. So we'll see how that goes. Expect to see a lot of traffic on the list and on the repo in the next couple of months. And I would appreciate any help from anybody if you have opinions about any of the open issues. That is all.
Cool. Excellent. In time.
Did it in time. We have 3 minutes left.
Perfect. Okay.
What
should we do now with the 3 minutes? Yeah. Oh. Yeah. No. But I could give you 3 minutes back, and you're the first one in the queue for the coffee.
Great. Thank you all.
Thank you for showing up. Thanks for the presentation.
I'm not on the list. Are you going to up issue that before it expires?
Oh, yes, I saw this expires in like 5 days, so I will push
Well,
out
the
an update.
16th, whatever the hell that is.
Yeah.
It's more than 5 days, but.
See you at the next session.
Well,
Thursday.
because it means I've got to ask for the. Yeah. Sausage making matters. Sometimes, not always. Depends on what's. If you let it
Move
expire,
away from the microphone.
I have to ask for that. But usually it's like.
You want to discuss something?
Expires.
Don't have time. Huh? Don't have time. I don't have time.
You don't have time? You're running somewhere?
You're gonna do it.
Have you had a chance to look at TLS slides?
Nope. I'm sure they are great.
No,
I'm
yeah, they
sure
can
they are
all-
great.
Yes.
No, I trust you that you produce excellent, better than.
So,
Right.
yeah, so that else.
I'm sure they're great.
Wireshark last night.